Hi again. Welcome to the session number 3, tutorial number 2, bottom-up estimating. Obviously, the learning outcome of this video is to understand the bottom-up estimating technique and being able to apply them in a project context. When I attempt to estimate either project duration or cost, bottom-up estimating is often a good choice. It helps to combine estimates for activities or work packages in order to estimate a larger portion of the project work. In other words, we start from the bottom in order to look at each individual activity or work package, which presumably should be easier to estimate than bigger pieces would be. And then we add together those different durations, different costs in order to get a better idea of how long or how much everything will take. If you find bottom-up estimating to be difficult to accomplish, it may be that your activities simply aren't decomposed enough. You want to have a good grasp on how long each portion of an activity will take for a resource to complete and have a good idea of what that resource's cost will be in terms of time and material. If you're not yet certain of that, you might want to speak to subject matter experts of your project teams to understand those activities better and help to break them down into small, easier to manage pieces. This can come in handy both with scheduling and estimating. Now, you can't simply add together these activities estimates for a variety of reasons. Just because something might take 3 days and another task 5 days, you can't assume that the project will take 8 days to complete. After all, there are differences in resources that might apply. So, depending on which ones we use, that could affect the duration and the cost of the given project. You also have to consider for the concurrence of activities, or in other words, the ability for several activities to take place simultaneously. In order to manage time and budget effectively, look at how you can run multiple activities at the same time by utilizing resources parallelly. The next, activity dependence is coming to play as well, because not only that will help to factor in how long the project might take based on what's available to complete the work, when it will also help to what resources you apply to each activity based on constraints, cost, priorities, and so on. Depending on our different cost, we might have made some different decisions in terms of how to allocate each of different resources. Different resources may charge differently, may spend time differently as well. These parameters may change how the resource allocation and utilization happens in your project. Now let's have a look at how exactly you do a bottom-up estimation from the work package. Once the work package is complete and the team member is comfortable with it, you can go on to develop the actual cost and duration estimate. In bottom-up estimating, you must be careful not to force an estimate on the project team members. If you force the estimates on the team member, you cannot expect to earn much commitment from them. That commitment is dependent on a free and open negotiation where the team member feels the estimate is fair and reasonable. You may use team members' pessimistic, optimistic, and best guess estimates developed in three-point estimation process. That technique allows the estimates to show the task uncertainty. Alternatively, you can use an analogous estimating technique with the team members. You'll look at the actual amount of work that similar tasks required on completed projects. If you have several projects and tasks to draw information from, you can quickly reach a consensus on how the current task compares to the other task. Then you can adjust the estimated work number to show that difference. Team member needs to actively participate in this discussion and in determining work number that you will use. Last, you aggregate the estimates for each activity in the lowest level of the WBS and roll the numbers up to develop estimates for the major deliverables and the project as a whole. You can use a number of mathematical techniques with the bottom-up estimating as well. The most popular and most accurate is three-point estimating, where each team member provides their pessimistic, optimistic, and best guess estimates for the calculations. To sum up, bottom-up estimating is the most accurate approach to estimate cost and duration. It also requires the most time. This kind of estimating involves the entire project team and gives them the opportunity to take part in developing the estimates used to measure their work. As a result, bottom-up estimating tends to develop a higher level of project team commitment than parametric estimating. In parametric estimating, where the numbers come from an outside source, like published rates, the team members may feel you have imposed the estimates on them. The drawback of the bottom-up approach, however, is that it takes more time than other estimating techniques. The work package is like a contract between you and the team member for their task. You need this contract to make the bottom-up estimating process work effectively with as little padding of the estimates as possible. Team members pad their estimates because they are concerned about the scope of their work expanding after they have started without any adjustment to the estimates. They foresee finishing late on the expanded scope and being blamed for missing their commitment. A similar result can happen when external events affect their ability to take the task to the done state within the estimated time frame. Because of these factors, work packages are an effective tool for clearly explaining to the team member that any changes to the work package are going to reopen the estimation process. In that sense, it gives them protection from scope changes on their task. That is why the work package documents that deliverables, the risks and approach to the task. You record the team members' estimates and you both sign the document. This removes a lot of anxiety from many team members who have previously been burned by the estimation process.